Guys, welcome back to another video. Thank you if you watched the last video where we actually went over configuring IP tables, which was so much fun. In this video, we're actually going to go over Windows command line tools. We're going to go over a few things like IP configuration, netstat, pinging IPs, tracer and route, as well as who am I. Now, from an internal perspective, we will use Windows, right, tools to investigate basic topology, but also see in detail the service and processes happening within a Windows system that are not directly visible without interrogation. So let's actually go ahead and get started with the first exercise. So what we're going to do first, we're going to go over IP configuration, which is a command line tool, or IP config rather, that displays the current configuration of the installed IP stack on a network computer. So when used with a particular command like /all switch, it displays the detailed configuration report of for all interfaces, including any configured wide area network mini ports, right? Typically used for remote access or VPN connections. So what we're going to do first is using the IP config command line tool. Okay. Just going to be doing that to identify the information such as the internet protocol configuration for the for the device that I'm using. So together with the TCP/IP network configuration variables, now we can see, this will allow us to, this will just test us for useful information about the computer, which is communicated with the network and what devices it is currently using to make that communication, right? So here we can actually view information about the Ethernet adapters attached to this device, and these are displaying three different network addresses from here, which is the 0.2 that it ends in, which is the correct assigned address. Additionally, we're also provided with IP version 6 addresses for the device. I'll actually take a look in a second. Just want to clear it out. I love a good clean screen. I'm actually going to make this bigger. All right, and just as I mentioned earlier, as far as the command with the /all, now we can take a more of a detailed, we can learn more detailed information about each device on this computer and how it's attached to the computer, right? And also in a great deal more information can be displayed, so we can take our time usually absorbing the details about the information. We can see host names. All right, we can also take a look at the primary DNS for this particular server, or the network rather that we're on, and the connections to each Ethernet adapter, and the use of the Hyper-V, working from the adapter 234, providing information about the configuration of those IPs of those internal devices. So we can also learn that the NetBIOS over the TCP/IP has been enabled on these devices as well. And we can use this command, another command rather, to identify the DNS values assigned to the device with this command here. We want to display our DNS. Perfect. So as we take a scroll through here, right, so we can see pretty much the DNS information is rendered to the screen, right, and it tells us all about the nature of connections reaching out to external and internal networks. So for example, we can clearly identify proxy data alerting us to further topology information, and further down, we're greeted with the domain information for for practice labs. So this allows us to move on to our next exercise, which is getting into netstat, which it usually displays, or it does display rather, active TCP connections ports on which the computer is listening. So the Ethernet statistics, the IP routing table, the IP version 4 statistics for the IP, the ICMP, TCP, and UDP protocols, and the IP version 6 stats over those protocols as well. So I'm just going to do a few things with netstat, nothing too much. So I'm going to use the command line tool for netstat naturally, right? So, okay, let's have it up and running. But I'm going to be using the netstat command line tool to display the traffic flow data, right? And the device routing tables. Let's see. Let me type. So it's just going to, as you can see here, to identify processes and ports they're listening to or have already established themselves on it. And then it also can be used to provide on-the-fly reports of traffic moving across interfaces. Now, as a security engineer, we used in a prior video, we used Nmap to see what services and ports were being broadcast. However, we're going to take a look at the same functions running on this particular server, DMO1, from the inside. I'm actually going to, once it stops here and allows us, we're going to enter the netstat command again, and then we're going to be giving a heavy readout of information in a second. There it is. All right, perfect. So the details now show relate to the protocol being observed, which is the IP address, which is the loopback address of, let's see, 127.0.0.1. And finally, at the bottom, we can see, here it is, we can see, right, that the machine address of 192.168.0.2, right? So the third column just displays the nature of the connection. And in this case, the connections have been established, right? So building on that command, we have additional options which in turn present more and different forms of information. So let's take a look at, once it allows me, netstat A here. Now this displays similar information, but also displays all active connections, right? And the TCP and UDP ports on which the computer is listening, right? So we can see here and the ports and whether they're established or, whatever they're doing, right? So we can actually take a look at a more verbose readout of ports and their condition that's provided with this switch. And it goes further to detail additional ports, and the listening state provides information on additional UDP as well as TCP protocols, which are monitoring the network. So to take a look at this, once it's done here, it should be done in just a moment, I'll be able to type in that command. Wow, it's like it hears me. When I say that, it just immediately just stops. But now we can see everything I mentioned as far as the top active connections to our device, right? And this also provides us with only the connections showing volumes of traffic, and usefully it presents the PID or the process identifier, right? So productively, this is a useful method for quickly displaying those ports in use. Now what we're going to do is actually combine the last couple of steps together by typing in another netstat command with, this time, A and O. Now what this does is, it's by applying the A switch, we display all the ports and their condition together with the PID that might be using or listening to the port for traffic to arrive or pass through. And we can also track the PID information to see the process activity. I'm actually going to showcase that here. We're going to take a look at our details and our PID. And we can take a look here for PID 4 from the netstat output. We can see that the PID process is being used by the system, should say system.exe usually, which is a netstat or NT kernel and system process, right? Now, by using netstat, we can actually investigate processes taking place on the network so long as the process is visible directly in Task Manager. It can be tracked down to provide a name, right? So this, of course, can be further investigated to make sure it's nothing concerning. And we can actually use this method to track down the other netstat processes, as well as or eliminate activities which we are sure to be secure and normal, right? So I'm just going to enter in the next command, which is the command R, or netstat R rather. So the routing table, as you can see here, the routing table is just a key piece of information to display topologies directly related to the device and the surrounding environment. So it details types of adapters, right, used to make connections and the gateways that the traffic is flowing through. And primarily is used as a troubleshooting tool, right, when investigating where the traffic bottlenecks might be occurring. So the options like -T, -U, W, or X show active TCP, UDP, raw, or Unix socket connections. And if we provide the A flag like we did earlier, in addition, sockets that are waiting for a connection, or rather listening, are displayed also, right? So now this display just gives us a list of all services that are currently running on the system, right? So displaying connections on TCP, which are waiting a connection, we can actually take a look at that here with this command, right? And it just gives us a constant flow of TCPs, right? And the output now just demonstrates the switch -TA or subtract TA, however you like to say it, which shows all the connections and listening ports together with the connection offload state, right? Excuse me. So now we're actually going to have netstat display statistics, right, about TCP traffic, and also force the addresses to be displayed in the FQDN format. So we're going to do the S, which is the statistics. We're going to take a look at the traffic here, TCP traffic, right? And we're going to take a look at the FQDN, which is the subtract F. And we have our active connections here. So to have a repeating function taking place, right, in that displaying the network interface statistics, right, and have them updated every 5 seconds. We're going to use that in just a moment once this is completed. Oh, there it is. It hurt me again. All right, so here with the -E, with just the interface statistics, right? Then the update every 5 seconds is this command here, right? So perfect. So now, if now we're expecting to see large traffic changes across the network, then manually monitoring the information as such is helpful, as the figures displayed here, excuse me, assist with network configuration confirmation. So usually when you're taking a look, when you're done, just want to stop command manually, right? With Control C here, then it'll take us back to the prompt. Now, what we can do now is we can check every second and print the results, right? If a process starts listening on the transmission control protocol port 80, right? So we can do netstat here, AN1, right? Perfect. So let's there, find 80. Perfect. All right, so often we're usually interested in specific ports, right? Especially if the port is being abused in some manner, as given in the output, port 80 has been specified, right? So we can watch the network, I'm sorry, the traffic changes occurring each second to see if anything unusual is taking place. And this will go on usually in perpetuity, and you can, stop it manually here, right? So this allows us to move on to, that'll be taking a look to our next exercise, which is taking a look at ping, which verifies the IP level connectivity to another transmission control protocol or internet protocol computer by sending the internet control message protocol echo request messages, right? So the receipt of corresponding echo reply messages, they're usually displayed along with round trip times, right? So the ping is the primary TCP IP command used to troubleshoot connectivity, reachability, and name resolution. So to get started, I'm actually going to ping our server here, DCO1. Let's see, do that here. All right, so I'm just using this to check the connectivity to the devices and to establish if they're up or down, rather. And it uses, as I mentioned, the ICMP echo. And here we're working with the IPv4 addresses, but the same concept is applied to the version 6 as well. So, so now let's continuously send packets to the command to terminate is entered. So we might perform this check if we need to constantly monitor an interface, which is under a maintenance check. So let's ping this command here. Right. Now, this method, right, is manipulating a number of times a ping should take place, which is useful when investigating devices which are having problems connected to the network. However, it's the beginning method where we can flood a device by request to get acknowledged out request. So this is just going to be going in perpetuity, and I'm just going to have it stop here for the purpose of the video. So finally, what we're going to do now is just modify the ping command to edit the number of echo counts to 30, each having a size of, let's say, 1,000 bytes. So 30 here, right? And then 1,000 bytes to this IP. Perfect. So now the modification of packet sizes is also a helpful tool when diagnosing network problems. But again, this technique is known as like to flood old server and routing devices by having them handle packets which are beyond their firmware capabilities. Now we're able to take a look for our next exercise, the tracer and routing. So the tracer diagnostic utility determines the route to a destination by sending the ICMP echo packets to the destination. And usually in these packets, tracer uses varying IP time to live or TTL values, because each router along the path is required to decrement the packet's TTL by at least 1 before forwarding the packet. So the TTL is effectively a hop counter, right? So what I'm going to be doing is using the tracer command line tool to read information, right? If it lets me type, I thought I was typing. So the command line tool to read information about packet paths taken, right? So let's see. So this can actually identify blocks on the network that show where the information is not being routed correctly. So Just to also break down the command, the H in the command is specifies a max hop of 5 steps, right? And given where we're going on the small topology, all hops would be effectively one step large, really. So now the trace is complete. So we're going to use the route command line tool also. So another method, right, for calling the routing table like netstat, as we used previously, netstat subtract r or netstat minus r is the route command. So in this task, we're actually going to be using the route command to display the same same route information, but useful to know a variety of commands which have similar functions, right? So we did a route print, and we're presented with an interface list attached to the device, which can be key to learning more about the network configurations. So importantly, we're also presented with an IPv4 route table, which shows us the active routes being applied to the network adapters, and we given the network destinations, any masking taking effect on the IPs. The gateway, the communications are traveling through the interface IP and metrics of data flowing, and we're also told if there's any persistent routes on the devices. Now, the route command also tells us that there is no persistent routing paths being used with this device on IPv6. So now we can move on to our final exercise, which is going over address resolution protocol, or ARP, which performs address to media, which performs, if it lets me type, which performs address to media controlled access to resolution for outgoing packets. Now, as each outgoing addressed IP datagram is encapsulated into frame, source, and destination MAC addresses must be added, which determining the destination MAC address for each frame is the responsibility of the address resolution protocol. Now, for who am I, right? This displays user group or privileges information for the user who is currently logged on to the local system. Now, if this is used without parameters, it just displays the current domain and username. So I'm going to do now, as you can see, what I just typed, I'm going to use the ARP command line tool, and I'll be using it to display entries into the address resolution protocol cache, which contains one or more usually tablets that are used to store IP addresses and unresolved Ethernet addresses as well. So this command is used also to display static and dynamic entries, right, into the ARP cache table, and we can see that the IP of the server device, right, against its physical address, the location or MAC addresses, and the type of relationship described as dynamic. So we're actually going to use another command as well to go over, similar to what we used with netstat for the AV. Now, attaching the AV switch, it just displays information in a more verbose mode and brings into view the additional interface of the loopback address. And actually, I'm going to add on to that with a new command here, and this time involving a new IP. So by applying the switch for the capital N, where did it go here? For the capital N here, we learn more about the interfaces by listing the entries for the specified interface, right? As we can see here, for the type, the physical address, the internet address. All right, now I can move forward with, now that we've covered ARP, address resolution protocol, we're going to take a look at the Who Am I command line tool, and I'll be using it to discover which user account is currently logged into the device. We know what it is, but it's nice to see it working in real time. Let's see, I'm always typing and it just not sure. There it is. And of course, I'm going to say the admin. Now, the output is a call to the Windows device to clarify exactly what level of authority is currently using the console interface. It's simple, but effective, right? As you can see, admin here. All right, now this brings us to the end of the video. We've covered, just for a brief recap, some IP configurations, some net stats. We pinged some IP addresses. We did some tracer and routing tables as well. We went over address resolution protocols and the who am I control as well. This was fun as far as the window command line tools. On the next video, we're actually going to be going over administering and deploying endpoint protection. That one is going to be super fun. Hopefully, I'll see you there. Stay curious, stay secure.